Hi guys, welcome back. And in this video, we will discuss about revenue in perfectly competitive markets. Now guys, we've already covered the cost structure of the firms, that is how costs behave both in the short run and the long run. So now we will move our focus on the revenues for the firms and how the revenue behaves for firms, right? Now when we talk about revenue guys, it basically refers to total earnings or incomes from the sales. So sales means that you are selling something and obviously you're charging a price for it, which is basically your selling price. So we need to understand that firms basically differ in size, they differ in structure, and they also differ in their ability and the extent of control and dominance they have in the market. And then what that does is, and this will obviously in turn affects that it sort of affects their ability to decide what price they can or will hold the power to charge, right? And for that reason guys, economists have divided the markets into two types of market structures, that is based on the degree of competition, and the size and the dominance of an individual firm, right? Such as, and those market structures are, firstly we have a perfectly competitive market structure, and then we have imperfect markets, that is imperfect competition, right? So guys, the thing is that if if you're dividing the market into two sort of structures, it's sort of, the thing is that both these market structures are different, which means that it will affect the firm's ability, not only the ability but the power to charge prices, right? Both these market structures are different and they will differ in terms of the firm's ability and the power to charge prices at different output levels, right? And that ability and power to charge prices at different output levels, guys, remember, will differ in both these market structures. And since it differs, now hear this out, since it differs, that is the reason, or since it differs basically, that will have an impact, on the revenues the firms will make in these different market structures, which also means that firms will have different revenue curves in both these different market structures. And that is why we're actually, and that is exactly why we'll see in the coming videos as well that, the revenue curves for perfectly competitive market structures are different as compared to revenue curves in imperfect markets, right? So, so that is why when we're studying revenue, we need to understand that what sort of market structure is the firm operating in, and who's, and whether are we making the drawing the revenue curves for a firm that is operating in a perfectly competitive market or under markets that are imperfect, right? So guys, now we will sort of move our discussion to the revenue structure, or the, in a market that is basically perfectly competitive. Now I've already defined what revenue is, that it is your total earnings from sales, right? In a specified, from a specified level of sales within a specified time period. And total revenue, the formula for total revenue is price times quantity, that is selling price multiplied by quantity sold, right? So the selling price is $5 and you're selling 1,000 units, your total revenue would be $5,000. Sweet and simple, right? Now, we know that economists are very much interested, whenever economists are calculating totals, right? Whether it is total cost or total revenue, economists love to calculate averages, and they also love to calculate marginals as well, right? Just like we calculated average cost and marginal cost and we calculate total cost, we will, in the same way, we will calculate average revenue and marginal revenue when you calculate total revenue, because calculating the averages and the marginals will definitely give us insights about the revenue structure of a firm, right? And how revenue behaves, right, in different market structures of a firm that is operating in different market structures, right? So, guys, first of all, what is average revenue? Average revenue, remember, guys, is equals to price. Average revenue is revenue per unit sold, and that would always be equal to price, and the formula is total revenue divided by quantity. Now, why will it be equal to price? Mathematically, it will always be equal to price because, so average revenue is revenue. So if you're selling, let's say, 5 units and you make a total revenue of, let's say, $100, right? So your average revenue would be $100 divided by 20, that is, sorry, $100 divided by 5, that is $20, right? Because you're selling 5 units and you're making a revenue of, let's say, $100. So on an average, your revenue is $20, right? So that's what average revenue is. On an average, what is your revenue per unit sold? So mathematically, it will always be equal to price. So average revenue is total revenue divided by quantity, and average revenue is, so total revenue could also be written as price times quantity. So if total revenue divided by quantity could also be written as price times quantity divided by quantity. So quantity gets cancelled and you're left with only price. So average revenue is always equals to price, right? So mathematically, remember that average revenue will always be equal to price, and this is irrespective of whatever market structure we are in. If the firm is in a market that is perfectly competitive, there's perfect competition, or the firm is in a market where there is imperfect competition, average revenue will always be equal to price. And like I said, economists are concerned about calculating average revenues and marginal revenues because it tells us about the revenue structures or the revenue behavior of a firm in different market structures. So first of all, whether we are in perfect competition or whether the market is imperfect, your average revenue will always be equal to price. But the way marginal revenue will behave in both these different market structures is different. Now, guys, what exactly is perfect competition? We'll be coming to that, and I'll just very briefly I'll give a very brief overview about perfect competition because that's not the purpose of this video. We are studying revenue, although we are studying revenue in a perfectly competitive market, but perfect competition will be covered in detail when we will study market structures. Okay. So, like I said, average revenue is always equals to price. And now we'll move on to discussion what marginal revenue is. So the formula is marginal revenue is marginal means incremental extra, and it's the same formula, change in total revenue divided by change in quantity. And marginal revenue is the change in total revenue that results from a sale of an extra unit, right? Or you could say that the correct way of showing it, I always tell my students to write the word incremental. It's the incremental revenue from selling an additional unit. So let's say on day one, on day one, let's say you are selling 5 units at $10 each and you're making a revenue of $50. On day two, the next day, you sold 6 units this time and you made $60. So what is the additional revenue that you gained, right? So the additional revenue that you gained was $10. So the incremental revenue that you gained, because this time you sold 6 units, right? So definitely you ended up selling an extra unit this time. So, and that resulted in an incremental revenue that was made of $10. So that's what marginal revenue is. Now, in order to graph out the revenue curves, remember guys, like I said, in order to graph out these curves, it is important that we take into account that what market conditions the firm operates in, right? Because the revenue curves will differ for different market structures, right? Whether we are in perfectly competitive market or imperfect markets. So we need to first study that what is the level and the extent of competition, right? Because firms will differ, because these market structures will determine the firm's ability to sort of decide whether it has control over prices or not, right? So in a perfect competition, remember when the competition is perfect. Now, a perfectly competitive market is a market, or the competition is perfect means that there's insane competition. Now, how perfect it is, how many firms are there in a perfectly competitive market, it's a subjective way of saying it, right? And remember that perfectly competitive market is more of a theoretical structure, and it does not exist in, its practical existence. No market structure is 100% perfectly competitive now, right? However, it's a good market structure to study and theoretically compare with other realistic market structures. So, but what economists do really mean when they say that the competition is perfect? It just means subjectively saying that the competition is insane. And when you say that, there's intense competition, you're actually referring to the firm's ability, because when the competition is intense, it sort of signifies that the firm is so insignificant, because when the competition is so perfect and intense, then the firm is actually so insignificant that it has no control over output or prices, right? So its output size with respect to what the total market output size is very, very insignificant proportion, right? So, guys, you see, in a perfectly competitive market, the most important thing is that firms in a perfectly competitive market, they don't have the ability to sell or to charge their own prices. They charge the price what the market tells them to charge or informs them to charge. And we know how market prices are determined based on demand and supply, right? So whatever the market price is, they sell at that price. An individual firm in the market will sell at the price the market offers them to sell, or the equilibrium price the market tells them or instructs them or directs them. That's the price an individual firm will sell at, right? Based on the interaction of demand and supply, whatever the equilibrium is. So the thing is that firms in a perfectly competitive market, since the competition is perfect, it's perfect. So obviously that would mean that the firms are selling identical homogeneous product. So whatever Mr. A is selling, Mr. B is selling exactly the same thing, right? So the competition is perfect and homogeneous. I mean, the product is homogeneous and identical, right? And these firms are very small relative to the market. And every firm in a perfectly competitive market is a price taker. That they're so small that they are too small to influence the market price. They don't have any influence on prices. They can sell as much output as they want, but they will sell it at that market price only, which is the equilibrium price, right? So that's a very basic overview of markets. I mean, perfectly competitive markets. And like I said, since we're not studying market structures, we're going to see a detailed overview about perfect competition when we will study perfect competition, right? So now, moving on to, I've sort of drawn a table here where I've included the values, and I've taken the price as $1, and you can see that the price is the same, right? Whether the firm is selling 1 unit or selling 2 units or 3 units, the price is the same because the firm is a price taker. It cannot change. So over a range of output, if it's selling more and more units, then it will sell at the same price. Now, the best way to sort of do is that you take a simple value that is $1 because it makes the calculation very easy. So I've taken the price as $1, right? So total revenue when you're selling 1 unit is $1, and if you're selling 5 units, your total revenue is $5. If you're selling 4 units, your total revenue is $4, right? So you can see that when the firm is selling 1 unit, the marginal revenue or the incremental revenue is $1. When the firm ends up selling 2 units, the additional revenue is $1. When the firm ends up selling 3 units, the marginal revenue is $1, right? So since marginal revenue is the incremental revenue or the change in total revenue when you're selling 1 more unit, so obviously when you were selling 2 units, the total revenue was $2. But when you ended up selling 3 units, the total revenue was $3. So what is the incremental revenue? It's obviously a dollar, right? And when you sold 5 units, right? When you were selling 4 units, the total revenue was $4, and when you're selling 5 units, your total revenue is $5. So obviously, when you from 4 to 5, when you move from 4 to 5, again the incremental revenue is $1, right? Even if you like apply the formula, the marginal revenue is change in total revenue divided by the change in output. So if let's say the quantities moves from 3 to 4, so the change in total revenue would be $1 because at 3 units your revenue is 3, while at 4 units your revenue is 4. So the change in total revenue is $1, while the change in quantity is also 1 unit. So 1/1 would give you a marginal revenue of $1. That's the incremental unit. I mean, that's the incremental revenue that you gain when you sold, right? 1 more unit. Because obviously, you see what it technically means is that let's say on day one, let's say on day 3 you were selling, let's say, 3 units, while on day 4 you ended up selling 4 units, right? So definitely on day 4 you did sell up an additional unit this time. So that resulted in an incremental revenue of, let's say, $1, right? So that's your marginal revenue basically. Average revenue, like I said, is always equal to the price. And you can see that the price is $1. Since that is not changing, the average revenue is $1 as well over the entire range of output. And if you calculate the average revenue through the formula, that is total revenue divided by quantity. So each time you divide the revenue by the quantity, you get $1. So let's take, a quantity of 3, and you divide the total revenue of $3 by 3, you get $1. And it's the same over the entire range of output. Each time you can calculate, the average revenue would be always equal to price. That is $1. Now, guys, we'll use this table to derive some important relationships between these revenues. And economists love deriving relationship between different variables. So for example, let's say that you're saying that the average revenue is always equals to the price, right? If average revenue is always equal to the price, and if average revenue is always equal to the price, and you're saying that the marginal revenue in this case is also equal to the price because the price is $1, and each time you end up selling an incremental unit, you gain an additional revenue that is exactly equal to the selling price, because this was only possible because the selling price is constant, it's the same. So the marginal revenue is always equal to the price in a perfectly competitive market. So if you're saying that the marginal revenue is equal to the price and the average revenue is also equal to the price. So if average revenue equals to the price and if marginal revenue equals to the price as well, then if this is equal to this and if price equals to marginal revenue, you could say that average revenue is also equal to the price, right? So what I'm saying is average revenue equals price. If average revenue equals to the price, and if the price is equal to the marginal revenue, because each time you sell an additional unit, the incremental revenue that you're gaining is actually equal to the selling price in a perfectly competitive market, because all incremental units are sold at the same selling price. So you end up getting an incremental revenue that is equal to the selling price of that incremental unit. So guys, the thing is that if price equals to the marginal revenue, so if this equals this, if this equals this, and if this equals this, then the average revenue also has to be equal to the marginal revenue, right? Simply, if average revenue equals to price and if price equals marginal revenue, then the average revenue also has to be equal to the price. Understood, guys? And I'll prove this why average revenue is also equal to the price. I'll also prove this mathematically as well. There's another way that I've written it below as well. So for now, something that I've written that I've already discussed as well, since every unit, and this is the same relationship that I've established here, since every unit brings in $1, every unit is bringing in $1, the average revenue is $1 as well, right? So which simply means that since $1 is the selling price, average revenue is equal to the selling price. Furthermore, since each additional unit sold, because now we'll talk about marginals, since each additional unit sold brings in $1, the MR of an extra unit sold is also $1. Since each additional unit that you're selling is bringing in $1, the MR of an extra unit sold, that is a marginal revenue that resulted, the extra revenue that you gained because you sold an extra unit, is also $1. Just like I said, let's say you ended up selling 4 units and now the next day you ended up selling, let's say, 5 units. So the incremental, you sold an extra unit. This is how you need to understand this. You sold an extra unit this time, the next day. Because on the first day you sold 4 units, but the next day you ended up selling 5 units. So you did definitely sell an extra unit this time. So that resulted in an extra revenue this time of $1. Because on that day you ended up only $4, but this time you ended up $5. So definitely you did end up an extra $1, and that extra $1 is obviously equal to the price, because that additional unit you're selling is definitely contributing an extra $1 to the total revenue, right? So that's how they're all connected basically. So average revenue, remember guys, is actually equal to the marginal revenue over a range of output in the market. If the market is perfectly competitive. So in a market that has insane competition, or you could say perfect competition, so if the firm is operating in such a market, right, if it's selling products in such a market that has perfect level of competition, so the average revenue will always equal to the marginal revenue in that, over a range of output. Now, you could also sort of mathematically do this as well, and we can actually prove this, because the equation or the formula for marginal revenue is change in total revenue divided by change in quantity. Now, change in total revenue could also be written as change bracket P multiplied by Q. Dot means multiply, so P multiplied by Q. Now, I could rearrange this entire thing as saying P multiplied by change in Q, because whatever this value is, this value will obviously be equal to this value, because they both are the same. I've rearranged it, right? And you also need to understand that you're saying change bracket P times Q. Since in a firm in a perfectly competitive market, since the price is not changing, the price is the same. So the change is actually in the quantity. So we could say that price multiply by change in quantity, because the change is actually in the quantity, not the price. So P multiplied by change in quantity divided by change in quantity. So change in quantity gets cancelled. Mathematically, it's known as delta. So delta Q divided by delta Q gets cancelled, and you are only guys left with P. So if you're only left with P, so technically MR equals to P then. MR equals to P. And if P equals to AR, then MR equals to AR as well. So we have proved this. So guys, now we'll see how the graphs of total revenue and average and marginal revenue looks like. So first let's see that, okay, so let's see how how would a average revenue curve or a marginal revenue curve basically look like, right? So we know that when you're selling one unit, your basically average revenue was $1, right? So we have a point over here, and your marginal revenue was $1 as well. When you sold 2 units, your marginal revenue was $1, right? And when you were selling 3 units, your marginal revenue was $1, and same, so on and so forth. And when you were selling 3 units, your average revenue was $1 as well. When you were selling 5 units, your marginal revenue was $1, and so was your average revenue. And so was the price as well, because the price is $1. So you see that all these curves are coinciding, right? They coincide. So technically, if you join them up, you end up getting a horizontal straight line. So this horizontal straight line is representing the average revenue curve. This horizontal straight line is also representing the marginal revenue curve. This horizontal straight line is also the price line, because this is also establishing the relationship between the quantity and the price. It's actually telling us that we are selling all these units at the same price of $1. And this is also equal to the demand curve as well. Now, why is this equal to the demand curve? We'll speak a lot later on. But just to give you a brief hint, remember that any curve that establishes the relation between price and quantity is a demand curve. So a curve that establishes the relation between price and quantity is your demand curve, right? So if the firm is selling 1 unit or 2 units or 3 units, which obviously means they're demanded as well. So definitely this also establishes a demand curve, right? So that is why we say that they all coincide, right, along the same line. So your average revenue curve and your marginal revenue curve, right, is basically a horizontal straight line. So that is why we usually say let's say if I remove this demand here, because this is actually demand curve as well. So average revenue equals to marginal revenue equals to your price. So when you say that average revenue equals to marginal revenue equals to price, what you're saying is that when you're selling, let's say 3 units, your average revenue was $1, so was your marginal revenue, and so was your price. And if you join them up, you get this horizontal straight line that represents how this is basically representing the behavior of AR, MR, and price. Simply telling us that price is consistent over the range of output, and so is your average revenue and marginal revenue the same, constant, and they're equal to each other. That's why they coincide on the same line, right? So moving on to the total revenue curve, guys. The total revenue curve is drawn like first of all, it starts from the origin, because when you're selling 0 units, you're not making any revenue, and it's an upward sloping straight linear line. So total revenue line is linear, it's upward sloping, right? Showing, and what is it showing? Whenever the line is linear, mathematically it shows that the slope is constant, the gradient is constant. So it shows that we know that the total revenue is rising at a constant rate, right? So the slope of total revenue, which is actually your marginal revenue, the slope of total revenue is your marginal revenue, is constant. It's showing that each time you sell an incremental unit, right? So each time you sell an additional unit, the incremental revenue is $1, which is your marginal revenue, right? So the slope the slope is constant, guys. So you can take this point, let's say the slope, let's say if point A is representing you're selling 2 units and point B is representing that you're selling 3 units. So the revenue over here is $2, while over here is $3. And if you want to calculate the slope between these 2 points, A and B, change in Y over change in X, right? That's how the slope is calculated. So the change in Y would be the change in total revenue divided by change in X would be the change in quantity, which will actually give you, which is the formula for marginal revenue. So if you plug in these values, the change in total revenue would be $1, change in quantity is a unit, 3 minus 2, so the marginal revenue would be $1. And if you calculate the slope between 2 points on a straight line, on this total revenue line, simply going to tell you, the slope will tell you simply by what rate your revenue is rising or going up, and you'll see that the increase in total revenue is always $1, right? So the total revenue line, guys, is basically an upward sloping linear line, right? Now, like I said, I took the example and I said that your price is $1. But how do firms in a perfectly competitive market get $1? So we have established how we have seen how we draw the average revenue curve. We've also seen how do we draw the marginal revenue curve. Now, I mean, you also need to understand that, okay, fine, if how would the firm decide? How would an individual small insignificant firm decide it has to sell at $1? So the firm will not decide. An individual insignificant firm out of the many thousands of firms, he or the firm will not decide. The market decides. The industry decides. The market of that industry decides. So the market decides, right? And the market tells, okay, fine, this is the price you need to sell at. And you see, so the demand curve for a perfectly competitive market is downward sloping. The demand curve is downward sloping for that entire market, for all the firms in that industry, in that market. And this equilibrium point is representing the market price. And then, so this is the price at which the firms will sell. And this price is taken by the fact that, we are extending this line horizontally is representing that this price is actually taken by, this is sort of indicating a behavior of how the firms will take that price. So the firms take that price and they sell it at that price. And that is how you get $1. So this $1 is actually the price that this $1 is the same price. This $1 is the same price that the market has set for this individual firm. Let's say this is firm A. Right? So the firm A will sell at $1 basically. So moving our discussion forward, and like I said, this $1 is basically the individual firm selling price. And over the entire range of output, we know that the individual price would be equal to the average revenue over this entire range of output. That would also be equal to the marginal revenue, right? And this curve, right? And this entire curve, we will say that this is also the demand curve as well. So this line is also representing the demand curve, because it's technically what it's doing is establishing the relation between price and quantity demanded as well. It's simply telling us that over this range of output, what quantities would be sold by the firms at what price, which is obviously constant. So it's establishing that an individual firm's market demand curve, right? An individual firm's demand curve, not a market demand curve. An individual firm's demand curve is basically a horizontal straight line, right? And we'll come to that, what the horizontal straight line really signifies when we'll study market structures in detail, right? Okay guys, so the last thing before I end this video is that the average revenue curve, like I said, is a horizontal straight line. So in a perfectly competitive market, the demand curve is also a horizontal straight line, which means that the average revenue curve is the demand curve, and they both are horizontal. They both coincide with each other. They both lie along the same line, which means that the average revenue curve lies along the same line as its demand curve. So the average revenue curve is basically the average revenue is equal to price, and over this entire range of output, the average revenue stays at $1, which is equal to the price, right? So for this entire range of output, the average revenue is $1, which is equal to the price. So that gives us a horizontal straight average revenue curve. And since average revenue is equal to the price, so technically, if average revenue equals to the price, and if price is measured on the horizontal axis, price is measured on the vertical axis and the quantity on the horizontal axis, then we could intuitively say that if average revenue equals to the price, right? If the average revenue equals to the price, and then we have the price on the vertical as well and the quantity on the horizontal axis, then we know from our previous study that the relationship between price and quantity is established by the demand curve. And if average revenue is price, then guys, if average revenue is price, then the relationship that the price and quantity is giving is the demand curve, right? So if we can so the entire pattern that the average revenue curve will take, the entire pathway that the average revenue curve takes is a horizontal pathway, indicating that over this entire range of output, the average revenue is constant. It's not changing, and that is exactly equal to the price. And if price is measured on the vertical axis and quantity on the horizontal axis, then over this entire range of output, all the quantity will be sold at the same price. So then this also becomes the horizontal demand curve as well, because we know that for a horizontal demand curve represents a perfectly elastic demand curve. So in a perfectly competitive market, the demand curve is perfectly elastic, indicating it's horizontal, which simply means that the average revenue curve lies along the same line as its demand curve, because the demand curve does express the relation between price and quantity. So you could intuitively say that, right? And that is the reason why the average revenue curve is the demand curve, guys, because the average revenue is price, and the relation between price and quantity is established by the demand curve. So if every point, let's say, on the average revenue curve is indicating the relation between what the average revenue is at a specified quantity, let's say at let's say this quantity, at point A the average revenue is $1, and at 2 units the average revenue is also $1, and both of them, point A and point B, the values at point A and point B are actually referring to the average revenues, which are actually equal to the price, then every point on the average revenue curve is indicating a relation between price and quantity. And the relationship, and then because average revenue is price, so the average revenue, the pathway of this entire average revenue curve takes the same pathway as the demand curve, so that makes the average revenue curve the demand curve, right? And that is exactly what I've written over here as well, that since the firm can sell any quantity it chooses at this price, that is $1, the same price. The horizontal line is also the firm's demand curve, because it shows that any quantity the firm chooses to sell, any quantity that the firm will choose to sell, whether 3 units, 4 or 5 units, will be associated with the same market price, and the same market price is actually the average revenue, right? Which is constant, which is the same. That's why we've written the word same. And last thing that before I end this video is that remember, guys, that if the price is unaffected, which means it's not changing in a perfectly competitive market, and if price is not affected by the variations in the firm's output, whether you increase or decrease output, the price is the same, then the firm's demand curve, number one, the firm's demand curve, number two, its average revenue curve, and its marginal revenue curve. Both these curves coincide. Use this word coincide. Don't say they are the same. I mean, they are the same, but then there's a difference between what we refer to our own understanding versus what we write in the exam. There's a difference between these two things, right? So at times we sort of refer to things for our own understanding to simplify it so that it's better for our own understanding. But it does not necessarily equal to that we need to write it in the same way in the exam as well, because it's our exam, right? So what in the exam you will write? The exam you will write that the firm's demand curve, its average revenue curve, and its marginal revenue curve, they all coincide in the same horizontal line. So that's it for this video, guys. I'll end here. Thank you so much for watching, and I'll see you all in the next video.